what's the probability of a student going to college in my honors class? There's a lot of information here. So what the best thing to do is to try to break it up, okay? So I'm going to draw a tree diagram that's going to help me figure this out. Okay, we're starting with my entire set of honors. And the first way that I broke it up for you is I broke it up into grades. A's, B's, C's, D's, and F's. And what I like to do is I try to like to label what percentage. What percentage got A's? We said 15% or 0.15 get A's. All right. 25% got B's. 35% got C's. 15% received D's. And 10% failed out. Okay. Now, out of the group that got the A's, we know that they're either going to college or they're not going to college. So from this group, from this A group, we got 0.8 went to college. I'm just going to use C for college, which means the other 20% are not going to college. I'll do C complement. Okay. B's, we said 70% went to college, so 0.7 went to college. So that means that 30% of the people that got B's did not go to college. C complement. In C's, we said 65% are going to college. So if 65% are going to college, that means there's 35% of this group that's not going to college. Okay. D's, 40% of these students are going to college, which means there's 60% in this group that's not going to college. And the group that got F, we said only 23% of that group was going to college. So if that's 23%, then the bottom should be 77% of that group is not going to college. So C complement. Running out of room here. When you make a tree diagram, it's telling you guys what to multiply. So to get, let's say, the group that got A's and are going to college, that's this line right here. That's the multiplication. That would be 0.15 multiplied by 0.8. If you multiply this group together, 0.15 times 0.8 is 12%. So what I'm saying right here, this 12%, this represents out of everybody in my honors classes, 12% of the kids received an A and are going to college. Okay, the next line down would be 0.15 times 0.2. That would be 0.03. So there's only 3% of my entire honors classes that got A's in the class but then decided not to go to college. So these are all your multiplication that'll tell you about each group individually. So why don't you guys take a few seconds with me, go ahead and type in all these numbers so we can get all these percentages down. Okay, so this group should be 0.175. This is 0.075. This next group would be 0.35 times 0.65. It's about 22.2275. 0.1225. We'll get all these numbers in. This would be 0.023. And last but not least, 0.077. Okay, so I've got all of these numbers that represent the population of my honors classes and what they're doing after college, what grades they got, and if they're going to college or not. Okay, so if I have a simple probability here, if I said, what's the probability of going to college? Well, there's a lot of groups that are going to college. So out of the A's, 12% are going to college. Out of the B's, we still have 17.5% going to college. And then we have to account for every group. Out of my C group, we have 22.75 going to college. And we're going to add all of these together. Out of the D's, we've got 0.06. And out of the F's, 0.023. We're going to have to add all of these numbers up to get the total percent of the students that are going to college. So it'd be 0.6055. Good. And then because we're doing conditional probability, and I'm making this video longer than it needs to be, what if I said, what's the probability that if we knew that the student went to college, what's the probability that student got a C in my class? So they got a C in the class, but we knew that they ended up going to college. So now I've got that conditional probability. I have to apply that probability law. So this would be the probability that they got a C and they went to college over the probability that they went to college. Okay, so in our case, the probability they got a C and they went to college, that's that line right here. If I'm tracing it, they got a C, they went to college, that's that 0.2275 on top. Over the probability that they went to college, well, luckily we figured that out over here. The probability they went to college was 0.6055. If we divide these two numbers, we get about 0.3757. All right, so what this tells me is if I knew that the student went to college, there's about a 38% chance that that person also got a C in my class. All right, so there's an example of a tree diagram to help us organize and finish, organize these problems to make them a little easier to understand. All right, I got one more quick thing I want to show you, and then we're all done for today. 33 minutes, oh, of course. All right, the probability of at least one. You're going to hear this quite a bit, okay? So every time you hear this verbiage, at least one, you have to know the easiest way to figure this out is 1 minus the probability of none. Okay, so quick examples. Sprite. Sprite used to do this advertisement where 1 in every 6 bottle wins a free Sprite. So 1 in 6 is a winner. All right, so to me that sounds like pretty good odds. So what I would do is I would buy 4. Okay, I figure if I got 1 in 6 as a winner, if I buy 4, there's a pretty good chance of me winning. So if I buy 4, what's the probability that at least 1 bottle wins? Okay, so in our case, the probability of winning is 1 in 6. So that means the probability of losing would be 5 in 6. So if I want to know what's the probability of at least one winning, that's going to be exactly the same as 1 minus the probability that no bottles win. This is going to be much quicker to find out. So the probability that no bottles win. Okay? When I buy these bottles, I have to assume that they are independent. Okay, so if I open one bottle and that's a loser, technically that should have no impact on whether the next bottle is a winner or a loser at all. Okay, so if I buy 4 bottles, what's the probability that none of them win? So the probability that my first bottle was a loss would be 5 out of 6. The probability that my second bottle was a loss would be 5 out of 6. Probability that my third bottle was a loss is 5 out of 6. And the probability that my fourth bottle was a loss was a 5 out of 6 as well. Okay, so that's just 5/6 to the 4th power. Sorry, I got out of screen there. So if I type that in, 5 out of 6, raise it to the 4th, that's actually the probability that they all lost. There's a 48% that they all lost. So, but what I have to do is I have to do 1 minus that. So if I do 1 minus that, so my calculator comes out, 1 minus that last answer, I get 0.5177. Okay, this tells me that if I buy 4 bottles, that there's about a 52% chance that at least one of those bottles is a winner. It's not bad odds, not bad odds. Okay, all right. You know what? I think I'm going to cut it out here. It's a 37-minute long video. I apologize for that. We got a quiz that's coming up, so make sure you guys study. And if you guys have any questions, remember, come on in. We're going to be doing this for the next few days, so I want to make sure that you guys get comfortable with it. Spend some time on your homework. Send me emails on questions that you have, and we'll see you soon. Okay, guys, have a good day.